3.2, use parallel lines and transversals. So I need to stress this before we get into these notes. These are short notes today, that all the vocab you learned in 3.1 is vocab, and all the names of these angles is all about position, okay? So I need you to remember corresponding angles are just angles in the same position. I need you to remember alternate interior angles are angles inside between the two lines on opposite sides of the transversal and opposite ends. I need you to remember that alternate interior angles are on the outside of the two lines and on opposite ends and sides of the transversal. And consecutive interior angles are inside between the two lines on the same side of the transversal. That vocab is set, that vocab is about location, and that is vocab and it's all about location. And I can't stress that enough. Because today when we go into these notes, we're going to make the two lines that the transversal is cutting through parallel. And now we get some mathematical properties that go with them. But those vocab words and that location is true without parallel lines. Okay, and I can't stress that enough. They're true without parallel lines. So we throw this big word on all of these, this if we have two parallel lines. Now we have a new rule that takes place. The vocab, though, stays the same. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent, okay? That was not true on 3.1 notes, and this is only true if the lines are parallel. So 2 and 3, or 2 and 6, I guess that's the number there, they're now congruent because of the parallel lines, okay? So let's practice this. And again, remember, we know they're parallel lines because we see these little arrows on them, okay? If we don't see those arrows, we cannot assume they're parallel. We have to have some proof of it, okay? So they give me right now angle 125 right here, 125 degrees. I shouldn't call it angle 125. Okay, they want me to find the other measures of some of these, okay? Well, because of my new rule, this 125 is kind of on the right side of that X, and so is angle 7 down here. That means angle 7 is also going to be 125, okay? And that's by corresponding angles. Again, you don't have to worry about the postulates. You could just, if you can tell me corresponding angles, I know they're congruent, okay? Now, using vertical angles, I could come over here to angle 1, and I could say angle 1 is also 125 because of vertical angles. Well, if 1 is, 5 is in the left side kind of, so it's the corresponding angle. So it is also going to be 125. Okay, and I can call that either corresponding angles or I could call it vertical angles because it's vertical with the angle 7, okay? Now, I'm going to be honest, they stopped right there. I'm curious though, can you tell me what angle 2 is, okay? Don't forget you have that 180 rule, so 180 minus my 125, well that gives me 55, so that means angle 2 is 55. Well, angle 4 is a vertical, so that one's 55. Angle 6 here corresponds to angle 2, so that one's 55. Angle 8 down here is vertical or corresponds with angle 4. That's 55. So the one thing I want you to realize here is if your lines are parallel, they can give you one angle. That's all they gave us, that 125. And we labeled and found all the rest of them, right? Because all of these over here were the 125, 125, 125, and 125. And then we can find all those green ones are the 55s, okay? They give us one angle on parallel lines, we can find all of them. All right, so let's come down to the checkpoint right away on corresponding angles, right? And they give us, we can see two parallel lines, the transversals cutting through, cut into 8 angles, and they tell us angle 7 down here is 75. And they only want 1, 3, and 5. I'm gonna be honest, we're gonna find them all because we can. But let's start with 1, 3, and 5. And I don't care with which one you start with because sometimes one is easier to identify than others. Okay? You like angle 5, it's 75 because of vertical. I like that. All right? So angle 7 down here is 75. Angle 3 up here is its corresponding, so that one's 75 because that's corresponding. And then if 5 over here is 75, angle 1 up here is 75 because it is corresponding to corresponding to 5 or vertical angles to 3. So we could do either one of them there, right? So corresponding or vertical. It just depends which one you put it to, okay? So either one works, okay. So we just found 4 of the angles. And again, the book or the notes didn't ask for it, but I think we can handle this. What is angle 2, angle 4, angle 6, and angle 8? Well, 180 minus that 75 leaves me with 105. So if this one's 105, this one corresponds to it. This one's a vertical. This one's either a vertical or a correspond, so we can find them all. Okay? They give us one angle, we can find them all. Questions so far? All right, let's move on. Page 2. 3 new theorems here. And again, I can't stress enough, these go to the parallel lines. They have to be parallel. If we have parallel, okay? So if these little arrows are marked, then, and lines are cut by a transversal line, the pair of alternate interior angles will be congruent. Okay, so these inside on opposite sides are congruent if we're in parallel lines. If we have 2 parallel lines and they're cut by a transversal, pairs of alternate exterior angles, these ones on the outside, they are going to be congruent. Okay, and the last one, if we have 2 parallel lines again, and the parallel lines are cut by a transversal, then the pairs of consecutive interior angles right here, now be careful here, are going to be supplementary. They are not congruent, okay? They are supplementary if we have parallel lines. So 3 sets of congruent, corresponding, alternate interior, and alternate exterior, but consecutive interiors are going to be supplementary. All right, move that paper, and let's try some of these. So once again, we always look for this symbol that they're parallel. If they're not parallel, we cannot do anything with these angles. There's no rule about them, okay? So be careful there. So because of this, the lines are parallel, so we know that this angle outside and this angle outside, what do we call those when they're outside on opposite ends? Alternate in exteriors, sorry, I almost said the wrong word. Alternate exteriors are congruent, right, or equal. So that means that 113 is going to equal the 3x minus 4. And we're ready to solve, right? Just algebra here, add 4 to both sides. And I'm not even making you put it in a proof form, right? 117 equals 3x. Divide both sides by 3. I mean, we could. That's what these things kind of are on the right is their explanation. 117 divided by 3, 39 there. So x equals 39. Because we know alternate exterior angles are equal, we can set those up. All right, 3rd page, which actually it happens to be our last page today, so kind of short ones here. And we're talking about a runway. Wow, can't get my paper to do what I want. Taxiway is being constructed that intersects 2 parallel runways. So here's our runways, and it tells us they're parallel. And this taxiway is my transversal cutting through, okay? And we know angle 2 is 98 degrees. The question is, what is angle 1? So because the runways are parallel, we know angle 1 and angle 2 are congruent, right? And I should put alternate, I'm going to run out of space, alternate interior angles, right? They are going to be congruent alternate interior angles. So angle 1 and angle 2 will be the same, which means their measures are the same, which means angle 1 can also be 98 degrees. Okay, so the 2 angles are the same because of alternate interiors. All right, number 2. Now, number 2 I need you to be very careful with, okay? Currently, I have an angle inside, and I have an angle on this outside. Do those 2 have a relationship? So if I just, again, I'll show you here. If I had an outside and an inside, if you think back on 3.1, are those corresponding in the same position? Are they alternate interior, both inside on opposite sides and ends of the transversal? Are they alternate exterior, both outside on opposite ends and sides of the transversal? Or are they consecutive interiors inside on the same side? And the answer is no, they're not any of those four. So currently, we don't have a relationship to be able to do anything here. So one thing that you can do is, and I want you to stress this one, because you can't do this to anything, you can move vertical angles. Okay? Because vertical angles are true no matter where and how they're drawn. When that X is drawn, if they're straight across from each other, you can move it. So this one right here, 3x minus 7, I'm going to move it to this side, 3x minus 7, because vertical angles I can always, always, always move, okay? Now, when I've moved them, what kind of angles are these two angles right here? Well, inside, on the same side, those are consecutive interiors, okay? And consecutive interior angles, we just know from our theorem, if they're between two parallel lines, which I see the parallel lines, they're going to add up to 180. They are supplementary, okay? So I had to move that angle, and I'm allowed to move verticals. That's one thing I'm allowed to do. And now I have consecutive interior angles, and they are equal to 180. So now I can say 3x minus 7 plus x plus 5 equals my 180. Okay, so I have a part plus part equals whole, right? Those are my two parts. I can join my like terms, 4x, join my negative 7 and 5 to make negative 2. I can add 2, divide by 4, and I get a decimal, and that's okay. It's possible. I get x equals 45.5, okay? But I had to move that vertical angle to make my two angles have a relationship that I know something to do with, okay? So the original angles out here, those two did not have a relationship, so I had to move an angle to get a relationship. All right. So last one here, number 3. It says up in example 3, that's the runway question, right? So let's draw that runway so we kind of have it. So we had our two parallel runways, right? Our taxiway came through. I had angle 2 down here, I had angle 1 here. And it says, suppose angle 3 is the consecutive interior with angle 2. So consecutive interiors on the same side together. So if angle 2 is down here, angle 3 needs to be also with the same side. And it says, what is angle 3? So let's go ahead and write our measurements. This was 98. And we found angle 1 was also 98 because of alternate interiors. Now we're looking for angle 3. So remember, these are same side inside together, consecutives, and together they equal 180. So I can do 180 minus my 98, and my measure of angle 3 is going to equal 82 when I subtract those. Okay? Okay. It's super important to know that vocab is true whether or not our lines are parallel. Okay, the vocab is always true. But now, to be able to solve for angles, we need the parallel lines to make angles congruent or supplementary, okay? So follow your rules. So homework tonight, page 157 to 158, 4 through 32 even. And then when you turn the page to 160, at the bottom of the page, there is a quiz. I want you to also do those 1 through 7 alls, okay? Show your work where necessary. Be really careful of the vocab. This vocab you need to know, so work with it, keep saying it, keep looking at it, and if the angles don't have a relationship, see if you can move one to have them have a relationship, okay? Any questions? Please let me know.